To the video lecture for Chapter R, Section 2. My name is Jorge Gavillan, and this is for MAC 1105, College Algebra. So, in R.2, we're going to be talking about the different objectives. Here you can see that we have 8 different objectives that we're going to go through in this particular section. So, the first one, the real number associated with a point P is called the coordinate of P, and the line whose points have been assigned coordinates is called the real number line. So, 3 cases of real numbers. The negative real numbers are the coordinates of points to the left of the origin, O. The real number 0 is the coordinate of the origin O. And then the positive real numbers are the coordinates of the points to the right of the origin O. And you can see here in the graph. So the next thing is the multiplication property of positive and negative numbers. So the product of 2 positive numbers is a positive number. The product of 2 negative numbers is a positive number. And the product of a positive number and a negative number is a negative number. Next thing we're going to talk about is graph inequalities. So here the first one, we have A is less than B, and you can see how it is on the number line. Here A is equal to B. Again, you can see how it's denoted on the number line. And then A is greater than B. Again, you can see how it's denoted on the number line. Here A is greater than 0 is equivalent to being that A is positive. A is less than 0 is equivalent to A is negative. So graphing inequalities. On the real number line, graph all numbers x for which x is greater than 4. On a real number line, graph all numbers x for which x is less than or equal to 5. So in figure 11, notice that we use the left parentheses to indicate that the number 4 is not part of the graph. And then for figure number 12, notice that we use a right bracket to indicate that the number 5 is in fact part of the graph. Then the next thing is we're going to find distance on the real number line. So here we have negative 4 is 4 units from 0, and 3 is 3 units from 0. Now the next thing we're going to talk about is absolute value. So the absolute value of a number A, denoted by the symbol, here we can see the symbol is defined by the rules. Absolute value of A is equal to A if A is greater than or equal to 0, and the absolute value of A is equal to negative A if A is less than 0. So computing absolute values. Absolute value of 8 is 8. Absolute value of 0 is 0. The absolute value of 15 is negative 15 is 15. Next definition, if P and Q are 2 points on number line with coordinates A and B respectively, the distance between P and Q denoted by D, the distance PQ, is simply the absolute value of the difference between B and A. So here the distance PQ is 7 minus negative 5, which is equal to 12, the absolute value of 7 minus negative 5. And then the distance QR is the absolute value of negative 3 minus 7, which is 10. Now distance is always positive. Next thing we're going to talk about is evaluate algebraic expressions. So evaluating algebraic expression, evaluate each expression if x is equal to 3 and y is equal to negative 1. So here we have 4 examples. So for the first one, substitute 3 for x and negative 1 for y in the expression x plus 3y. And so we end up with 3 plus 3 times negative 1, which is 0. For b, we have that 5xy, so it's 5 times 3 times negative 1, which is negative 15. For c, we have 3 times negative 1 divided by 2 minus 2 times 3, which gives us 3/4. And then for D, we get the absolute value of negative 4x plus 3, which is the absolute value of negative 4 plus 3 plus negative 1. And then we get 13. Next one is determine the domain of a variable. So the set of values that a variable may assume is called the domain of the variable. So here, finding the domain of the variable x in the expression 5 over x minus 2 is all numbers x such that x does not equal negative 2, since if x is equal to negative 2, the denominator becomes 0, which is not defined since we cannot divide by 0. So when you get an example like this, what you do is you just simply look at the denominator, you find which values we're going to make that equal to 0. The next one, we're going to use the law of exponents. So if a is a real number and n is a positive integer, then the symbol a to the n represents the product of n factors of a. That is that a to the n is equal to a times a for 9 factors. And if a does not equal 0, then a to the 0 is equal to 1. Now if a does not equal 0 and n is a positive integer, then a to the negative 1 is equal to 1 over a to the n power. To the negative n power, sorry. Here the law of exponents. So we're going to use different laws of exponents. So x to the negative third times x to the fifth power. We're going to add those two, so it becomes x to the second power. For b, x to the negative third raised to the second power is equivalent to x raised to the negative sixth power, which is 1 over x to the sixth power. For c, 2x to the third power is equal to 8x to the third, which is 2 to the third times x to the third. For d, 2 thirds to the fourth power is equal to 2 to the fourth divided by 3 to the fourth, which is 16 over 81. And then for e, we get x to the negative second over divided by x to the negative fifth, which gives us x to the third power. So again, using the law of exponents, we're going to write these expressions so that all exponents are positive. So for a and b, x and y does not equal 0 for both of them. So here you can see that what we did with a is we separated the x's and the y's, which is probably the best thing to do. Now in class, I'm going to show a different way of doing this, which I think is perhaps a little easier. So we have x raised to the second power, which is 5 minus 3. And then we have y raised to the negative third power. Now, since there's a negative to the negative third power, we're going to write that as a fraction. So our final answer becomes x squared over y to the third. For b, we're going to go ahead and distribute the negative 2, the exponent negative 2. And then we're going to go ahead and take care of the negative exponent. So for the numerator, x to the negative third raised to the negative second is x to the sixth. And then for the denominator, we're going to end up with 3 to the negative second times y to the negative 1 times negative 2, which is simply 2. And then you can see here that what we end up with is 9x to the 6 over y squared. The next one, we're going to evaluate square roots. So if a is a non-negative real number, the non-negative number b such that b squared is equal to a is the principal square root of a, and is denoted by b is equal to the square root of a. So we're going to evaluate square root. So the square root of 64 is 8, because 8 to the second power is 64. Square root of 1 to the 16 is 1/4, because 1/4 to the second power is 1 over 16. Square root of 1.4 to the second power is simply 1.4. Square root of a to the squared is simply the absolute value of a, and a is any real number. Using scientific notation, when a number has been written as a product of a number x, where 1 is less than or equal to x less than to 10 times the power of 10 is said to be written in scientific notation. Now, converting a decimal to scientific notation. To change a positive number to scientific notation, count the number n of places that the decimal point must be moved to arrive at a number x, where 1 is less than or equal to x and x is less than 10. If the original number is greater than or equal to 1, the scientific notation would be x times 10 to the n power. If the original number is between 0 and 1, the scientific notation would be x times 10 to the negative n power. So here we have, each number in scientific notation. We have a, b, c, and d. So the first one, the decimal point of 9,582 follows the 2. So we're going to count left to the decimal, stopping after 3 moves because we end up with 9.582, which is a number between 1 and 10. Since 9.582 is greater than 1, we're going to write it as 9.528 times 10 to the third power. For b, the decimal point in 1.245 is between 1 and 2. Since the number is already between 1 and 10, the scientific notation for that will simply be 1.245 times 10 to the first power. For c, the decimal point in 0.285 is between 0 and 2, so we're going to count stopping after 1 move because 2.85 is a number between 1 and 10. Since 0.285 is between 0 and 1, we're going to write that as 2.85 times 10 to the negative first power. And then for d, you can see that we moved the decimal place 4 places, so we're going to end up with 5.61 times 10 to the negative fourth. So changing from scientific notation to decimal, so 2.1 times 10 to the fourth, you can see here that that becomes 21,000. 3.26 times 10 to the negative fifth, because 0.0000326, so we're going to move it 5 places to the left. And then 1 times 2 to the negative second power simply becomes 0.001. And that's the end of R2. Thank you.